So we're going to talk about WebRTC today, and let's get started. So, I have sort of divided this presentation into three parts. WebRTC is a relatively new topic. I know there are lots of folks probably out there on the bridge right now, and you guys are gurus already and have followed up WebRTC quite well. But since it's a relatively new topic, I know that there are folks out there who are trying to get their arms around what it's really about. So what I've done is the first part of the presentation is relatively high level. We're going to talk about where WebRTC fits in all the real-time communication options that we have out there. Where is Genesis offer fitting in? What are those practical use cases? And where exactly the technology is? Is it ready? And our own Genesis WebRTC services is in restricted release. So we'll talk about what's real, what's not real, and things like that. Second part of the presentation, we'll do a deeper dive. We'll talk about some messaging, talk about scalability, security, a bit about quality of service, and then I'll end that by talking about HA, talking about deployment modes, referencing and links, and few things like that. So so bear with me as I sort of build the momentum, talking about the high-level scenarios first. Okay, high-level overview. This picture actually, a lot of few good things did happen as we were part of Alcatel-Lucent, and this one I distinctly remember. This is the view of Paris in nighttime from the Eiffel Tower. Of course, this overview is in daytime, so let's go right into that. Let's start with just talking very basic stuff of what real-time communication is. And I know that we are in real-time communication business, and we all know about it, but what I've noticed is that especially when we talk about WebRTC, a lot of people think about video. And it's probably because that most of our demos, are showing video as one of the cool functionality that is part of WebRTC. But just as real-time communication, I think it's very important just to get that definition out of our way and make sure that we have those bases covered. So real-time communication is information shared instantly with acceptable latency, right? So voice call, perfect example of real-time communication. Video call, example of real-time communication. However, one thing that doesn't really come to our mind when we talk about communication is that data sharing, is the chat. So a screen sharing, application could very much be part of that real-time communication. So, and of course, we have seen a lot of examples of that real-time communication, right? So things started off with ICQ when I was in college. I, of course, wasted a lot of time there that I'm not proud of doing ICQ. But then, all these messengers, the Yahoo Messenger, the MSN, the AOL, all of these became very popular. They later added voice capabilities in it. It was very jittery. It wasn't really good. But lately, of course, with Skype, with FaceTime, with Google Hangouts, we've seen quite a bit of improvement, and I think most of you guys or most of us actually use Skypes, and we've been using FaceTime also through our iPads and iPhones and things like that. So all of that is part of real-time communication. However, there is a problem as far as when we talk about the browsers. So most of these technologies, especially the voice and the video part of it, they've been proprietary technologies. And these proprietary technologies haven't really worked very well when we talk about all the browsers that are out there. So browser-to-browser communication has been pretty much limited to chat. So, no open standard. It hasn't been free. It hasn't been reliable. And without the plugin option, it's just not there. So Flash has been out there. We have had some customers, especially in EMEA, through our partners, adopting Flash to SIP gateway, and we use Flash. Most of us do through YouTube and other means, from the browser. But of course, again, Flash was proprietary. It required a plugin. So, important question as we try to understand WebRTC is that why is it the case that from the browser we haven't had that ability so far to really make those voice calls and video calls with an acceptable quality that we sort of see, in Skype and through things like FaceTime and stuff like that. So the question that those difficulties are important to understand to really put WebRTC in right perspective. The first aspect there is that web itself has been client-server model, and that request going to the web server and the web server rendering those pages and with dynamic aspects coming in those pages, even playing files and videos. Now for real-time communication, it is mostly peer-to-peer communication. The client and server model doesn't fit quite well. It cannot scale well, and it cannot handle the acceptable latency aspect that real-time communication needs. Now, when we talk about peer-to-peer, of course, Napster and other applications come to our mind. So peer-to-peer communication has been happening through the browser, but there are challenges about when we look into peer-to-peer communication too. And those challenges are that the browsers and we are behind NATs and firewalls, and it's not easy to establish that peer-to-peer communication. The technology has improved, and Skype relies on that to some extent. But as I said, most of these applications have those tricks that has been mostly proprietary so far. And lastly, I would say we are at a very high-level discussion right now. So last thing I would say is about the quality of service. The voice quality in the Yahoo and the MSNs and the AOL when we use those messengers, it was not good. And the reason it wasn't good had to do a lot of things. It was not just about the bandwidth. It was about the codecs. It was about the unreliability of what that bandwidth is, the variation that there would be, and the codecs were not ready too. So a lot has happened the last 5-6 years. Most of these things on the quality of service side, a proprietary thing that Skype has been able to do. But that evolution of a lot of that proprietary technology is now sort of ready to then be part of this open standard WebRTC technology. So as we define WebRTC, web real-time communication open standard that enable browser to browser real-time communication without plugins. As we talk about this real-time communication, important aspect to highlight is that it's not just about video, of course. So you could have one-way video, you could have just audio, and then you could also have just data capabilities. And the data connection is definitely part of WebRTC standard. There are lots of applications that are possible just through exchanging data between the clients, which is part of the WebRTC standard too. WebRTC, as part of an open standard, is unique because whatever is required for that real-time communication to happen is embedded in the browser stack itself. I think that's one of the most important thing about WebRTC, that no plugin is required, the audio codecs that needs to be used, the ability to punch holes through the firewalls, and we will talk a little bit detail about that, the quality of service that needs to be maintained. All of that is part of what is inside the browser stack itself. And that is what it is making it, very interesting, especially in the customer service scenarios where we, as Genesys, don't really want to deal with all of that complication of real-time communication, right? So we don't make phones. We definitely do not want to make, and invest our engineering resources into quality of service on the endpoint side, right? So the reason it's exciting for us is that the whole open standard activities, sort of led by Google, is behind that, and it is being handled on the browser itself. And we'll talk a little bit more about what exactly it means. So on the right, you see this picture here that, at a high level, gives you an idea of what all components are part of it. So you have the browser technology, you have the APIs that are involved. These are JavaScript APIs to make it easier to write that code, on the web page itself. And of course, the web server is involved. So HTTP and WebSockets. I guess at the high level, what I want to emphasize through this slide is that underneath WebRTC, the technology that is being used is HTTP. It is relying on RTP. So it's not that there are a lot of new technologies that are coming to bear here. They are existing technologies that are being used. It's just that all the progress that we have made on quality of service, all the tricks that we have learned, or these companies have learned, as Skype, FaceTime, and other things have evolved, these are being added as an open standard activity in the browser itself. So voice, video, and data. Two open standard activities are behind this, so W3C and IETF. So if you will, just at a high level, think about the WebRTC call flow. So it is the APIs that the programmers will use to embed this within the browser or within the web page itself. So W3C is looking into the API aspect of standardization, and IETF is looking at on the wire, the protocols involved and behind the scenes. No plugins, no Flash, no Java, no Silverlight required. Everything is embedded within the browser itself. And the real promise is that it would work multi-platform, different devices. So we will talk a little bit as to what browsers really support WebRTC, but even with Firefox and Chrome and their Android version and even Opera, close to 1 billion endpoints out there today support WebRTC. I know that we, as consumers, have not been using WebRTC to that extent yet, but believe me, it's getting out there, 1 billion and more. And if we talk about even those three browsers that I just mentioned, and you look at any statistics, whether in North America and EMEA or even worldwide, that pretty much cover 60 to 70% of the browser as well. And that's a little bit controversial as to exactly what number it is with Chrome, with Firefox, with Opera, but it is a large number of users and endpoints out there do support that. Also, through different devices, I'll talk a little bit that there's a activity going on to enable WebRTC on those platforms where it's not there. I'll talk a little bit about RequestTech and that company. So they are actually providing APIs already that could work from iOS and Android. And I know that we will be looking on that within our product of Genesis WebRTC services as well. So with that little bit background, let me actually talk about where does our product fits. And it is, again, going to be at a very high level. One thing which I will not do today is, not go into Genesis WebRTC services TOI, which product management usually does, and they will provide all that documentation. But I just want to go at this point at a very high level where it fits, why it is important for customer service, and then I want to sort of close the section by talking about those high-level use cases, which I think is pretty practical and can help us sell this stuff even now, right? So the approach that we are taking from Genesis perspective is that the two aspects here. The first is we are providing a Genesis WebRTC gateway. By the way, the marketing name is Genesis WebRTC Services. The gateway, sounded a little bit more like the SIP gateways and more hardware sort of a device. So, but it isn't necessarily a gateway. And what that gateway does is it converts the signaling, the WebRTC signaling, and I'll go into that detail. What is the rope and what is JSEP and what that signaling has. But basically, there is a signaling that is happening through the JavaScript API that folks are using from the browser. So we convert that signaling on the back end to SIP. So if there is a customer out there that has already deployed SIP, then to allow their consumers, the customer's consumer, to get the flexibility to use WebRTC for audio or for video or even for data sharing, they just need this gateway to convert that on the contact center side. They do not need any investment if they have already invested in SIP. So I think that is one of the important points. The second point this strategy has is that those customers who do not yet have SIP or who are evaluating or do want to make that transition, WebRTC is one of those technologies that can give them another important reason to adopt SIP. And it doesn't have to be just video. It's very important for us, all of us, to understand that it is not about video. A lot of people tell me that video hasn't been that successful in contact center. You need to have the right backdrop and things like that. And what it is only about probably 20, 30 seats in 1,000, 2,000 seat contact center. So certainly the WebRTC can handle video, but a lot more than video. And for those customers out there who are evaluating SIP, WebRTC can be one extra trigger for them to go and take that step. Then it doesn't really have to be just SIP alone. So the WebRTC services or WebRTC gateway that we support can handle on the agent side a WebRTC enabled endpoint or the browser. So there's a lot of talk about the HTML5 desktop that engineering is developing. A lot of us are very excited about it, but I think the most exciting aspect of that desktop would be when it embeds the WebRTC endpoint in it. So then not only on the consumer side, the WebRTC use case would be very relevant, but also on the enterprise side. I have few customers already looking into that aspect, that they're saying, hey, for our remote agent, for our branches, won't it just be cool if we'd have the thin client browser-based desktop and it has WebRTC embedded in it? So this WebRTC gateway can convert the signaling to SIP. It can also, on the enterprise side, support a WebRTC endpoint, which is a browser. Another unique thing about this gateway is that it is handling media as well. So it is not one of those gateways or the approach that SIP server takes that we just handle SIP and we go to media server to handle media. It is very important because of the reasons that I'll highlight as we go down in this presentation, that there are different codecs involved, and although the open standard is evolving, it is evolving standard. It plays well for us at Genesis because it gives us an opportunity to add value and provide the necessary transcoding that is needed. So this WebRTC gateway handles RTP also. It stays in RTP path, and as we talk about those call flows, I'll highlight why that is the case. And it handles any necessary transcoding that needs to happen on the codec sides, and we'll go into the codecs in a little bit. So what does that WebRTC services offer to the customers if they buy that? So there are two things that is the part of the product. So we are providing that WebRTC gateway, which does the things that I just described, and then it has APIs that can fit in, that can make that programming on that website easier. It also, there are different standards as WebRTC was evolving. I'll talk about the JSEP and rope part. But we provide that API that can plug in to that website code to enable those buttons, to make that communication happen, to make it easy for the customers to do that. So either you could consider that API, you could consider that as an SDK, and we do have in SIP endpoint now the support of VP8 and video codecs. So this API is sort of going in that step that we will make things easier, provide that sort of SDK to embed this code into the website. So very high level, Genesis WebRTC capabilities. I'm not going to go into detail of each of these. This is part of what the PMs are going to provide as part of their TUI. But this sort of shows you what's there, what's not, and I'll cover that in a section in a minute as well. So two-way audio only calls, two-way audio and video calls, transcoding is provided. We support Google Chrome. So you can read these things out, but these are part of the product management sort of documentation and TOI. So I'll leave it at that, and we can come back to it if you guys have questions. These are some technical features that are part of that WebRTC services right now. The codecs that we support, we do not support Opus audio codec. I'll talk about the minimum requirements for the audio and video codec. So I don't want to go into the detail of it just now, but just wanted to let you know that at a high level, these are the capabilities, and you can come back and check these things in detail later. So with that, I'm going to go into use cases and also ask Dan. Dan, are there any questions that I should address right now?
I've not received any. I don't know if you see any in the chat box there, but I have not gotten any on this end.
Okay, no problem. Let me quickly see if I see any questions here. So again, reminding you folks that if you have questions, as I might miss them going through the material, just ping Dan, and he will be able to then.
Hey Deepak, one did just come in. Randy Parker's asking, do we know the time frame this will be released in the Genesis Cloud offering?
No, I don't know yet. And I think the main reason for that is that there are just lots of things on their plate. I know I'm pushing them to have eyesight and SmartLink and few things like that as well. So I think it's not in the roadmap that I'm aware of right now.
Thanks.
On Genesis Cloud. So. All right, so what I want to do right now is just talk about few of the use cases that I think are relevant and that we can sell now, because I think there's a lot of questions around what is possible, what we can sell to the customer. Is it just the smoke in the air and some some cool technology that will be good a year or so later? Is it stable enough? But I think there are certainly practical use cases that should work for customers right now, and those are the ones that I want to highlight here. So just give me a second. Okay. So this slide just talk about those high-level scenarios, that browser-to-browser communication, browser-to-phone communication, 911, browser to CRM communication. So these are scenarios which are possible with WebRTC in general, and why it is making a lot of people like myself pretty excited. However, what I want to talk are the practical use cases that can work around existing Genesis product or solution that we offer. So this one is one of them, e-commerce proactive engagement. So an example being, let's say, somebody's browsing on an e-commerce website, and we provide them a proactive chat, and through that proactive chat, of course, there's a conversation that starts with some context. But as the customer or consumer is talking to an agent, the agent offered to just have a voice conversation. And the voice conversation can be enabled through a button, just comes up in the chat window, and the conversation just starts, right? And this voice conversation, along with the chat, could also be then, escalated to screen sharing or data sharing or co-browsing. Now that co-browsing, screen sharing, I know co-browsing, for example, will be part of e-services. However, the WebRTC technology itself, as I said, that it involves that data exchange too. There are companies out there, and Requesttech is one of them, and I'm going to talk about Requesttech in a little bit detail, but there are companies out there that are using WebRTC technology not just for audio or video, they're also using it for file sharing. And that could definitely be a part of that use case too, although our product does not yet support that. So this use case, if I stick to this use case itself, it's talking about escalation of that chat with audio, and then including co-browsing, which is already part of e-services, to give that experience and that consistent experience to the customers. They don't have to pick their phone and dial again, and we don't have to worry about reaching out to the same agent who's doing the chat and making sure that they have the right context. It just makes things very easy for the customer just to have that voice conversation right there while they're having chat. WebRTC through email. So let's say we are aware of those use cases through email. Somebody gets an email. In that email itself, they have a link. When they click on that link, immediately they're connected, or they go to the contact center. The WebRTC session is established. The way it goes and reaches the contact center is that it will go and hit the IVR first. It will be on the IVR side, nothing different. It will be same routing logic. You could play prompts. You could play, video and queue and things like that. I'm going to talk about some limitations here in a minute, but the point being that from within that email, you could click on that link, and it could start a voice conversation. And through WebRTC and the product that we support today, the data can be sent. So some call context can be sent to. So the agent, when this interaction is routed to an agent, the agent would know that it was about that email, and a little bit more context about what is that interaction is about. And of course, then it can be escalated to co-browse or something else as well. So as we talk about WebRTC and its use cases, I think it's very important to see how it fits together with our digital customer service and other e-service and other use cases. And if we put this WebRTC functionality in that context, I think it is pretty powerful. And even with this restricted release that we have with some limitation, it could still work quite well with our customers. Kiosk and mobile agent, I think the kiosk use case you guys are already aware of. whether it's in banking or whatever that use case might be. But basically, you do not need a SIP endpoint. You have a WebRTC-enabled browser. Kiosks are usually, within a particular enterprise or a bank or something, so the bandwidth is not an issue. Even the devices of the kiosk itself, you have more control as to what you can install. However, WebRTC makes it free. It's easier. You can install that browser. And I think the quality issue also, we all have used Skype. We all have used FaceTime. I think with the codecs that WebRTC has, the quality is pretty much similar to, if not better, with Skype and FaceTime as we see. Of course, the standards are evolving, obviously, but it has all of those, the advancement over the years that we have made. And when I say we, I mean general we as the whole technology industry, and the evolution that we have seen from those old days of voice being on Yahoo to what we are now used to from Skype. And we all use cell phones, right? And cell phones are not perfect. The quality is not as good as landline. But I think it's also about flexibility. It's also about the ease of use. So I think even though the WebRTC might not be as good as picking up the phone and talking, I think the flexibility that will provide to the consumer will be good, and I think that will result in an adoption. So video use cases, definitely part of it. I think video is the one that we talk mostly about when we talk about WebRTC, so I don't want to focus on that aspect a lot here. But customer support help desk scenario, video is in play. One-way video for premium service in banking and investment. I think there are already customers out there that use maybe Adobe Connect, maybe Cisco or other stuff to give that flexibility to some of their customers to have that video conversation, premium customers. I think the issue with not having Genesis solution, of course, is that those interactions are not routed consistently and reported through our system. The agents have to go and go to a different room. Those conversations are scheduled outside the usual contact center system. And when it happens through our solution, is of course we can provide the consistent routing and the IVR treatment, the same sort of reporting. So the agents do not have to have that experience where where it is a sort of a separate sort of interaction compared to the contact center being routing all those interactions, whether it's email, chat, or voice. Healthcare, United Healthcare is one of the customers that the use case, that the link that I shared in UK, not Genesis customer, but it is a Request-Tech customer. However, the use case is pretty relevant, and the use case is that it's a follow-up appointment. You don't need to go and meet the doctor. It's a video conversation. You could use any browser that supports WebRTC, and if you put Flash in there, pretty much all the browsers are covered. But I think in the healthcare sector or area itself, vertical itself, there is a lot of use of that video use cases. So there are a lot more video use cases that are, I think, relevant out there, but I just wanted to point 3 because I think we do talk a lot about video when we talk about WebRTC. So
Deepak,
let me...
I've had a couple questions come in if we want to cover those real quick.
Let's do that, Dan, yes.
Okay, so the first one is, do customers have to pay extra for Genesis WebRTC Gateway, or is the price included in SIP interaction?
No, it is not included. I think we are providing a value which is worth some money. So WebRTC services is a separate sellable item.
Okay, and can we report on all WebRTC interactions in Infomart, including who initiated the video, agent or customer? All
right. So as this is a very relevant question as I bring this slide up, which talks about the reality check, what's real, what's not there yet. It is in restricted release, of course. So what I'll say about that reporting is that as of now, no extra effort has been made to provide that that unique reporting just for WebRTC. However, that said, the way we want to position it to our customer is that this interaction is no different from any other interaction like voice, email, or chat. It could be, if it is a voice interaction, it's pretty much similar. It's just that it is giving consumer the flexibility. And on the contact center side, of course, if you have SIP, it's no different. So if you really want to see and understand from the reporting perspective if the agents have been involved in this sort of interaction, it can easily be handled by the key value pair or custom data to create that custom field in the report and then pull up reports like that. So I think right now engineering has been and product management, they've been focusing more on getting all that extra functionality that is needed. On the reporting side, it will be custom for now, but it would change in the future.
Okay, that's all the questions at this point.
Okay, so let's talk about a few of the limitations of the restricted release. So I think most of you guys understand what that restricted release means. We want to go through product management. The product management needs to be careful and then want to make sure that we pick those initial customers carefully. There are some minimum version of SIM and other products that are required too. Primarily, we want 8.0 or 8.1 customers. SIP is nice to have, obviously, but then, as I said, those customers, who are looking into SIP, it's a good to talk to them about this stuff as well. So the multi-party video conferencing can be a use case with WebRTC. There are customers, there are partners or people in this ecosystem in WebRTC that do support that. But our focus so far has been on those use cases where we can support conferencing as part of WebRTC, but within the contact center. We are not yet, our WebRTC services product is not like a Meet Me conference right now. We are also not providing screen sharing as part of WebRTC. So WebRTC technology can certainly have that data sharing capabilities, but our product doesn't allow that screen sharing using WebRTC. Of course, we can use Genesis iSight. We have co-browsing in e-services. So we have all those nuggets around it, but we don't use it through that WebRTC services. Only audio recording is supported, and even on the treatment side, although we talk about playing video in queue, video on hold, but I think this restricted release as it is right now, I think has some issues with playing video treatments. So just wanted to highlight that too. And only Chrome is supported as part of this WebRTC services restricted release as of now. Very soon they're going to support Firefox. Firefox already supports WebRTC. It's just that we haven't done that certification or integration testing within our product, so it is supported only in Chrome. Now, this aspect that it only supports Chrome, there are various ways where we can talk about this. One of them is that when we try to talk WebRTC, voice, video, and real-time communication from browser, one easy way to say is that, look, even if Chrome supports it, you can have these use cases which I just discussed in the previous slides and enable them. So the JavaScript or the logic behind the scene in the browser can enable that only when the browser supports it. So you don't have to ask the customer any question. The script can be smart enough to say, all right, this browser has that functionality. I'm going to allow a talk to us button to be enabled on the browser. Certainly, as more and more browsers start supporting it and we start certifying them, that capability will be available for all the browsers that are out there that will support WebRTC. Now, another important element is that if you throw in Flash, so we've been talking about Flash to SIP Gateway for a while. There are already customers in production, referenceable in EMEA, that use Flash to SIP technology for pretty much similar use cases that we are talking today. And we all use Flash as a technology in YouTube, so we've been using it, and about 98 or 99% of the browsers and on the desktop especially, we all have Flash. So Flash is a technology that works. If you throw in Flash with WebRTC, it can pretty much give you a coverage of all the browsers that are out there. And although Flash is not embedded in the browser, since 98, 99% of the endpoints already have it, it's pretty much that for consumers' perspective, they do not have to download to utilize Flash. Okay, so on the codec side, I'm going to show a slide in a bit as I talk in detail about WebRTC, that what are the minimum codecs that are required to be supported for audio and video in WebRTC. However, as I was talking about limitation, I thought I'll just bring it up right away. On the website, we are supporting G711 and VP8. VP8 is one of very good codecs, and Opus is missing here. Opus is a very good voice codec, one of the best one that's out there. Tony Simic and I was talking about it. Tony Simic is very excited about it, I know. So just to highlight that the restricted release right now supports G711 and VP8. It does not support H.264, and there's a bit of a tussle on the video codec out there between Microsoft and Google, but this is what it is for now. I know that in the next sort of iteration that will be released for WebRTC, H.264 will be included, and Opus as well. So that is in roadmap, certainly. DTMF is not supported. SRTP and secure, the exchanging of tokens through SDP supported. DTLS is not supported. Now, if you guys don't know what it means, I'll try to cover that up when I bring those relevant slides back in. But basically, DTMF is one aspect which is in works as well. Security through SRTP is supported, but DTLS is, is part of WebRTC that our restricted release doesn't support right now. Okay, so WebRTC story can be really very compelling even today if we throw in few extra factors. And we need to be careful as to, when we should talk about those and when we should not. But I know that most of you guys have sort of a good sense of that. So, but let me just throw this aspect out there. And I talked a little bit about that flash to sub gateway, right? So if you throw that flash or sub gateway out there, it will pretty much cover all browsers. And there is technology out there that will provide SDKs, and Requestech, one of the companies that we partnered with in Europe, to bring those customers live, Bank of Greece and AK Bank. So that Requestech actually allows or has SDKs for mobile devices for Android and iOS. I've been showing, and some of you have seen the demo that I have. You could pretty much make those video audio calls from the apps itself. I think within engineering, within the product, we have recognized that fact too, that especially for those use case for premium customers, we don't want to say that it works only from few browsers, and especially mobile has to be in the picture. So our engineering is looking into it. However, the technology has the support, and even the open standard, I think Google right now, and they are saying that they will provide APIs even for those platforms that don't support WebRTC today, and mobile will be part of that too. But Requestech and few companies like that do support those APIs, and we can partner with them and provide that functionality if it's really needed now. But I think our product will soon add those functionalities as well. So, our product is not taking advantage of the data channel, but file sharing, screen sharing is definitely something that we should think about, or we should talk about as we talk about and educate our customers and tell them about WebRTC. So that WebRTC standard certainly includes data sharing. We do not have in our product right now, but if that is relevant, that is something we can work with the partners to bring that to our customers. Requestech actually today has the technology where they can provide Meet Me, Adobe Connect, pretty much like GoToMeeting functionality that can be routed through Genesis, scheduled through Genesis. It has screen sharing. It has, whiteboarding. You can raise your hands and things like that. So that functionality is something that, when we talk about WebRTC as a technology, it is there. But I do want to point out that Genesis WebRTC Services doesn't support it. Again, but I feel that if there are important strategic SIP deals out there, or if there's a big customer, and if they need something like this, that what I'm trying to say is that these functionalities are there. We could try to work to bring that together within our solution and offer to our customer. But again, we have to be very careful when to talk about that and when not to, especially when it's not in our product. Okay. Any other questions came up, Dan, that I could address?
Not at this point.
Okay. All right. So let's have a deeper dive and talk a little bit more. I know that most of you guys there, this being a G-Factor session, would be interested in that. However, as I said, I know that WebRTC is a new topic, and then there are certainly a lot of people out there which just wanted to understand that at a high level, so I wanted to cover this section, so here's the deeper dive, right? So this is sort of an architecture just to talk about in detail what's exactly inside the browser. What is that API? What is the browser stack doing, right? So it is providing the audio-video engine. So by that, the ability to capture the camera, the audio. Most importantly, using the codecs. So the codec is a crucial point, is a crucial element in providing the quality of service, right? So that codec aspect is within the browser itself, and we will go into a little bit of detail as to what that does. But one thing if I have to point out about that codec is, and what has been improvement in the last 4 or 5 years, is the simple fact that when somebody is behind internet, not only we don't know exactly what bandwidth they have, but there's a variation. There are a lot of other things that are happening on that pipe. So what the codecs is trying to do to improve and provide better quality of service is that they're trying to adjust in that variable rate of bandwidth. So if you've heard a little bit about, let's say H.264, it's about different profiles. So same codec, the codec won't change for low bandwidth or high bandwidth. Same codec which is trying to adjust and provide the relevant quality based on what's the available bandwidth, and the congestion control and jitter and all of that stuff. So audio-video codecs, SDP offer-answer model. So pretty much like SIP, as some of you and most of you, SIP signaling. So you're trying to do a handshake with that SIP signaling, and then the offer-answer model of SDP. There's an extension over the standard 3.2.6.4 RFC that JavaScript session establishment protocol JSEP has. So those extensions are part of this WebRTC, and those are the extensions that we have to support as we provide that gateway. And by the way, I'm saying WebRTC gateway, but to be sure, it is Genesis WebRTC services. And then the stack that handle ICE, and I'm going to go into the detail of that. Let me just say that ICE stun and turn is used to punch holes and through the firewall and connect that peer which might be sitting behind the firewall too. I'm going to that detail through a different slide right now. So these are 2 slides which I'm going to skip these 2 slides, and you guys can come back to it later, because I think I'm going to cover most of these topics through the dedicated slides. But if I just have to pick 1 or 2 here just to say what's new in WebRTC, it is platform and device independence. It is secure voice and video, so it relies on HTTPS, existing browser-based technologies. So HTTPS and signaling, SRTP on RTP. So it is secure from that perspective. I talked about TLS and DTLS as well a little bit. Audio and video codecs. So the best audio and video codecs that we have today in the market sort of are part of within this this technology and in support of this browser, VP8 or Opus. So, and the evolution of those codec technologies I was talking about, how they adjust to the bandwidth that is available. Reliable session establishment, punching hole through those firewalls. So let me skip these 2 slides. I'll come back to a few of these topics in detail through dedicated slides. But let me cover this one though. So this slide points out what are those minimum set of codecs that WebRTC standard says that should be supported in the browser to be WebRTC compliant. So on the audio side, it is Opus and G711, and Opus is a very good codec. It is not that known or part of lots of endpoints out there. So it's still a little bit new, and I have a section on quality of service. If I get time, I'll try to tell you what are those differences in these codecs, and especially those keywords that can help you talk a little bit smartly, right? However, for this slide, for the purpose right now, Opus and G711 are the audio codecs minimum that should be supported. And on the audio codecs, the minimum codecs is agreed upon. So the standard body agreed that these are the 2 codecs. On the video, there is a bit of a tussle going on. And maybe tussle is not the best word to describe it. Maybe I should say that there's a war going on pretty much between Microsoft camp and the Google Camp on the H.264 and VP8. So that hasn't settled yet. But you know, as in Genesis, right? So we have written T-Server that would work for all of those switches out there. And I don't know how the story or the Genesis script would have been if CSTA would have been really successful, right? The point I'm trying to make is that although WebRTC is an evolving standard, if there are some gotchas out there, if there are some codecs that, you know, the standard body doesn't agree, I think we, as Genesis, can still add a lot of value by taking care of all those gotchas. For example, if we provide the necessary transcoding that is needed, so at least from the contact center side and from the consumer side, we are adding value that we can then charge for, right? So it, you know, by saying that on the video side there hasn't been an agreement, I think that shouldn't translate to, oh, this is not yet ready enough to be, you know, for us to sell. I think even if there is no agreement on video for you know, for whatever time to come, I think we, through our WebRTC services, we still add a lot of value in the product. Through these slides, I just want to touch base on the call flow. And although most of you are not going to write the code, it just gives you a little bit more sense as to what's happening behind the scene from the browser's perspective. What is that that needs to go on the website, on that browser? What code needs to be written? What are we providing through the APIs? So the first thing, there are 2 or 3 important things. The first being the get user media. So this is what the APIs in the WebRTC standard provides through the JavaScript to the browser. So you know, you're trying to, as a programming language, trying to get the camera and the audio. You are trying to put some profiles and constraints. If you want to say that, you know, I want of certain quality, you know, there's some flexibility that you can you know, through that API you can express. However, it will depend on the bandwidth. It will depend on how then the browser and codec adjust on that. So, you know, then there's a media stream. So basically the first thing that you're trying to do is that you're just acquiring that camera and audio, and you're using those APIs to do that. And, you know, as you've seen in demos, it proactively always asks for permission. So it's not that behind the scene some programmable code has just taken control of your camera and audio. There's always a way to prompt the user and make sure that they give you permission even for every interaction. Then the next important thing, of course, is the peer connection. So one of the main reasons why it has been difficult for this browser-to-browser real-time communication has been that, you know, that the other browser has been behind the NAT and firewall, and the peer-to-peer communication is just not, has been easy to establish. But now those technologies are out there, and, you know, why not make all of those tricks that these companies through their own proprietary technology were providing, it is now part of the open standard out there. So that peer connection is establishing communication between that other peer. It uses ICE. I'll go into ICE in a little bit detail in a separate slide in a minute. And then, of course, there is an SDP processing, right? So if you think about signaling and offer answer model, you know, one day my 10-year-old daughter actually saw one of my slides where it listed SIP, and he immediately asked me what is SIP. Very hard to explain, but I think I'm learning that lesson that if you can really explain that complicated technology to somebody like a 10-year-old or 5-year-old, that's how you have to, you know, or we have to make it simple for our customers also. So I try to struggle to explain. I was trying to say, hey, you know, if you meet, let's say if you need 4 or 5 languages, and other child or a friend that you see in school also knows 4 or 5 languages, what are you going to talk to them first in to figure out what language they really speak so that you can speak on a common language? And I asked her that question, and I think the kids are smarter, at least my brain is working slowly. So she immediately said that, hey, you know, we will use the sign language. And I think that's it. That's great. That is probably, you know, one common way where you have the signaling protocol, which will go and talk to the other peer and say, okay, what codecs you want to talk to it and all of that, right? So that signaling aspect is definitely part of the API. The API uses JavaScript session establishment protocol. We are using ROPE, and now since I'm mentioning it, let me just highlight that. So ROPE was one of the signaling or signaling aspect that was part of the early standard in WebRTC. It is the offer answer protocol that we are using because it has a little bit more on the wire signaling stuff in it. But we provide the APIs that would allow the ease of use. That is why JSEP is being used, because of its ease of use for the programmers. So as part of our APIs that we offer, we provide the flexibility that the end user just have to write those JavaScript API, and internally behind the scene, our communication or the Genesis communication happens over the rope standard that we use for signaling. So anyway, the peer connection is a very important part of it. The most important part is being ICE. I'm just going to bring that up in a separate slide. Then of course, adding the stream of media that you got from that get user media. You take that stream, you have the connection established, you throw that over that connection, and boom, you have a real-time connection, whether it's video, audio, or just data, right? So this picture sort of tells you what was the status quo without that peer-to-peer connection. Basically, the real-time communication had to go from a media server or a web server. This is not scalable. That's where the latency comes in. That's why it was difficult to offer that from the browser. From peer-to-peer communication perspective, it will look something like this. And as I said, Skype and others do use it. Napster for file sharing use that. So that is the peer-to-peer communication that is required to make sure that it can provide that extra level of latency and that you need in a real-time communication. However, the problem, of course, is that the peers are behind NAT and firewalls, and being behind NAT and firewalls, it is not easy to communicate with them. So that's where ICE comes into picture. That's part of the WebRTC standard itself, and the WebRTC relies on that, and it's very important that we understand that aspect of WebRTC. So it is Interactive Connectivity Establishment Protocol, and that's the RFC if you want to impress people out there. It uses two technologies to do the firewall traversal. The first technology is STUN, which is Session Traversal Utility for NAT. So what STUN does, it think of it this way, that if you want to have a peer connection, you go to a web server and you want to talk to that endpoint or the browser. Actually, let me flip the slide. So this slide shows that a little bit detail. So there are two browsers here. They're behind the firewalls, and you know that what firewall is exposing, it's a public address, but the internal address is that 192.168, whatever. Now you want to make the peer-to-peer connection. It's not easy to do because their ports and IP addresses not exposed. So STUN is a well-established way, which is out there, how to get rid of this problem or how to get past this problem. What STUN server does, it will relay the reflexive address, so then the communication between these endpoints can happen. You can go into a lot of detail about that, but the point being that it helps to establish that communication between the endpoints by giving you that reflexive address. However, the STUN itself doesn't solve the problem all the time, and sometimes we just have to rely on another technology, which is TRN, Traversal Relay Around NAT. So the Traversal Relay Around NAT would be that in that case, if the firewall is very, very strict, if RTP and other media are not opening up and things like that, so you need a media server in the public domain which will relay the RTP for you between these two endpoints. So what that means is that this slide here shows that the TRN server is actually going to relay the media. The disadvantage of this is, of course, is that it is an overhead, and that's why WebRTC uses ICE, which sort of has both of these technologies embedded within that within the umbrella of ICE. So it's going to try the STUN first, if that works, and most of the time it does. But when it doesn't, it has to rely on TRN. And that is why you will see that when we are doing WebRTC demos, and in fact I was doing it just the other day, when you are in one of those customer side, banking or insurance, their firewalls are strict. There are problems and issue with video. So if you are going to show WebRTC demo to the customer, I would strongly suggest that you actually try to go there evening before or something and make sure that it works in the the network that they are providing you. Usually they provide you a guest network which has even more restriction, and sometimes that video communication doesn't happen. Maybe we need to do more in the demo environment that we are providing to make sure that even for those extra constraints that those network poses, we could still punch those holes properly. But we have what we have. I also want to point out that there are some improvements in the demo side. Brad Townsend was pinging me. He is actually not on the bridge today, but the G Brewery demo that you've seen, there are more stuff that is out there. They're trying to make it available to more folks, so that demo is going to improve. And we are trying very hard to even get that thin client desktop embed a WebRTC endpoint, at least for the demo purpose, so that we can really show what is the cool thing around WebRTC to our customers. I did not go into too much details about it. Dan, are there any questions out there on the bridge?
Not at this point.
Okay. So, silence audience. All right. So, I think the ICE, the stun and turn, and even the quality of service aspect that I will highlight, we are not handling all of that from within our product at Genesis. The only reason we need to know enough about it is to talk smartly to the customer and to convince them that when they ask the question about security, when they ask the question about quality of service, when they ask these questions that it is difficult behind, we should be able to smartly handle that. But what's really happening is that we as Genesis are not investing into that directly. And I think that's the important part of the story as well, that there's an open standard body out there which is trying to take advantage of all the innovation that has happened. It is trying to make it free and public, and it will give the consumer the flexibility to use what we have already sort of relied on Skype, FaceTime, Google Hangouts sort of technology out there, right? So it is not one company that we are going with, Skype or Microsoft, and only their engineers are trying to make this work for the consumers out there. We are providing the gateway. We will plug this technology into the contact center, but the security, the quality of service, it is part of the open standard. And when it is part of the open standard, our typical play, that when the technology is proprietary, there are always restrictions, the innovation is controlled, and we have seen when it is open standard, open bodies, Google, all the other companies out there, when they are behind it, the innovation, just goes well. So it has all the best of the things that is needed to handle all those complications. So the reason we need to look into this when we are educating ourselves and our customers about WebRTC is not necessarily what Genesis is doing. It's just that when you talk to customer, or when we talk to customer, of course they want to make sure that it will be good enough for the consumers that they are going to offer it their customers, right? So on the protocol side, what does the WebRTC stack has? It relies on all standard protocols. It's not building anything from new, except from the fact that it is embedding all those tricks that these proprietary technologies like Skype and others had in the browser itself. So if you will see on the application layer, it is using HTTP, it is using WebSocket, which is sort of a part of the HTML5 stuff that is going on there. WebSocket is not necessarily mandatory, but it can rely on that. It relies on RTP and SRTP for that media. It uses the SDP offer answer model with some extensions that typically, that sort of exchange. It uses ICE, stun, and turn, which is not new for WebRTC itself. These are the technologies which have been out there. They've been pretty common to reach out to those endpoints behind the firewalls. WebRTC now is just using what are the applications protocols out there to make it possible from the browser, the real-time communication, that is. On the transport side, TLS, TCP, DTLS, UDP, and SCTP. Okay, so the secure TCP. Now, these could be jargons to some of you. I know there are quite a few on the bridge right now who know a lot about this already. For the sake of time, I'm not going to go into the detail of each of these right now. The point I'm trying to make is the WebRTC uses on the security side, on the application layer, the existing protocols. It's not building anything new. So from the risk perspective, right, it's a new technology? Yes. Does it, is it using any new protocol or innovation which is not out there? Not really. So that is why, we could probably have a little bit more confidence as we try to convince and educate our customers that, hey, it's an open standard. It is using all these technologies at HTTP and through SIP that you are already used to, and there's nothing new or nothing that's really out of the whack that needs some time to establish. Besides the fact that the browsers needs to adopt that and provide that within their stack. Security. So now, few of these questions would almost always come up when you talk to customers about WebRTC. Of course, the first conversation might not, but as we talk to those IT guys and all others, they will ask. So let's go into that and try to understand how we can smartly address those questions. In almost all of these cases, a short answer would be that we are relying on the WebRTC open standard. However, that's probably not the best answer that you want to give to your customer. You want to tell them a little bit more about it, right? So from Genesys perspective, if you're talking about security, we are not handling what's there in the browser, right? It is the WebRTC standard that is going to take care of that. Yes, we will provide the APIs that will rely on the functionality that is within there in the browser stack, right? So it relies on HTTPS, so it's for signaling, it is an HTTP communication. It relies on HTTPS, no surprises there. On the media side, it is RTP and SRTP, so no issues there too. Pretty, two ways to handle that, which is almost out there already. It does have DTLS that I pointed out that we do not support. If I have to describe DTLS in a very, very small way, it is about that sharing of that security token and how secure is the sharing of that security token. It could happen through SDP, through headers and some tweaks there that we support right now. But the DTLS is another way to do that, and that is the part that our product doesn't have, but WebRTC has. And in the next iteration of WebRTC, I think we are going to support, and it's in the roadmap. And the browser does ask for every interaction to take control of the microphone and the camera. So it is not that there's some program or some logic behind the scene would just grab your microphone and camera and just have it going. I think that control has been added. So now we support SRTP for 100% of the interaction that is going to happen from the browser to the Genesys WebRTC gateway. So it is always going to be SRTP. The SRTP from the WebRTC gateway to the enterprise endpoint side is optional. So you could enable that, or you could just have RTP going. But on the browser side, it is always SRTP. And HTTPS can be enabled through the common means. I don't think I have to tell anything new about that. So I think on the security aspect, the story is simple, and that's what it is. It is that, hey, WebRTC is relying on HTTP and RTP. There's a secured version of that. The TLS is already out there, so there is nothing new. It is relying on those technologies to secure this communication, which you're already aware of if Mr. Customer, you're aware of voice over IP, and if you have played around with it a little bit. So we are not adding anything new, and our gateway just supports that. So if you go a little bit into the WebRTC product itself, and I'm going to do a time check here. Dan, any questions so far that you see? Actually, let me see that.
Yeah, the one question that came in was back when you were talking about the demo piece is, do we have any time frame on when we think the WebRTC demo is going to be available through GDemo?
Right. I think what Brad was trying to tell me just 15-20 minutes back when he pinged me is that tech marketing now does have the ability to provide all of you the access to that through the GDemo capability. So that is what my understanding is. It is not just restricted for few people, because I think they are opening it up, adding more servers and all of that. There has been some challenges around the fact that to have this demo going on the consumer side, you could show Jew Brewery or whatever that site is, that you embed this technology. On the agent side, to really show that well, the screen pop and all of that, it was interaction workspace, and then you had to do VPN. And the reason being that if they virtualize everything in the hosted image, there are issues about codecs and video and all of that. So that's why it needed to show that through the interaction workspace. What we are asking now is, hey, won't it be cool just to have thin client browser desktop embedded WebRTC client in it, so we could really show the true power of it, the whole use case. So the short answer is yes. I think tech marketing has the capability now, and they're going to make it available for lots of folks out there. With the small caveat there that it is still in restricted release. So what that means is that PM wants to have a little bit more control as to which customers go and have that second or third stage of conversation. Have we done the evaluation? So all of that process that you are probably aware more than I am about that restricted release itself. So I think there's a bit of a caution around, and that's why probably even those TOIs, and by the way, the deployment guide, there's a white paper, there's a deployment guide, there is frequently asked questions. So there is some documentation out there which, as part of this deck that I'm going to share, I'm going to point links to those documents. The reason why you haven't seen all of that material is that because some of that was in works, but also because of that restricted nature of this release. So that TOI is not officially happened. It will happen somewhere around the sales kickoff time frame. So important thing though, if it is a good conversation that your customer is interested in, if they're already using video, if they're interested to have this capability on the browser, if it helps sell you SIP, absolutely reach out, talk to them, reach out to me and other folks, and we will provide you all that information. But soon, all of this in GDemo, all the documentation in the next month or two will be released for the wider field. Okay. All right. So let me actually, what I'm going to do is I'm going to browse through a few of these slides pretty quickly because I want to go to two sections. That is one about deployment and the other about quality of service. So this slide, as it shows, the agent is SIP agent. It shows the fact that, oh, by the way, RSMP. So whenever you see in some documentation RSMP, it is the WebRTC gateway, but the way Engineering internally was using this term, it is the rope signaling protocol that we use, and that was earlier part of the WebRTC that did not get standardized, but got standardized by JSEP. But it is the rope, it is the media, it's the proxy. So that's the acronym they're using. So just think about the WebRTC gateway. What this diagram is showing is that, of course, it is handling signaling and media, both of them. Why it would handle signaling is probably something that you could easily understand, that we want to provide call controls, the SIP server is already there, and things like that. We are also, this gateway is handling signaling because we have to, of course, convert it to SIP internally. But the reason it handled media is that, to have that, the thought that you could have that SIP phone just directly connect to a WebRTC device is not really exactly true. Even for SDP, there is a bit of an extensions out there, right? So, so we have to provide transcoding for media, and we have to be in the media path. So it's not a true peer-to-peer communication if you will look from Genesis perspective. Even when the agent has a Chrome or a WebRTC enabled endpoint, as of now at least, and it is being looked into, but as of now at least, not only signaling, but even the media goes through that WebRTC gateway. SIP server, MCP can be involved. That's why we could play prompts and provide consistent routing. On the prompts, of course, right now that video in queue has some issues, but that will be sorted out, I'm sure, before any customers goes live or even deploys in their lab. I'm going to skip some of these slides unless you have any questions. Just describe SIP endpoints and how the agent, and this is sort of a broader vision that is important to highlight to the customer sometimes. Maybe the slide is not the best slide, and we need to improve upon that aspect. But basically, what we're trying to say that, hey, we are providing you all of that necessary access gateway functionality. In case of WebRTC, we think it's a strategic and it's an important technology, so we are providing that gateway ourselves. But if it is some other technology, we through partner or through other means, we will provide that necessary gateway. So the consumer has all the flexibility to come from any device of their choice, browser, WebRTC, Flash, any SIP client, PSTN, mobile phone, and in front of your contact center, in front of your data center, you will have the necessary technology in place to convert that. So at least on the back end, if you have invested in SIP, you pretty much don't need anything else besides SIP. Here I have two interesting call flows. I'll try to go through that as quickly as possible, but the material is out there, and you will get this information as part of HLA or even the white paper. So this just shows the fact that from the consumer's perspective, this is, in the consumer use case, an anonymous user. So the gateway is handling that anonymous request and converting that on the back end, on the enterprise side, or the SIP server side, to SIP. So it could be a registered endpoint. In that case, it will send that register request to SIP server. But in the consumer use case, it will be anonymous request. That anonymous request will have some restrictions in the sense that only inbound interaction can be made. You cannot make an outbound interaction. So of course, for necessary reasons, it's anonymous. We have to take care of that. Now, one part to highlight, and this is something related to security also, since this WebRTC is embedded in the API or the JavaScript code that is in the browser, we're not really saying that we're exposing this API somebody to just call these APIs directly. What it really means is we're giving this API to the company or our customers who have a website, and they are going to use these APIs from their website in the embedded code which is behind on the website itself. So it is not going, this API is not going to the consumer directly. So from that aspect, I think it is important to kind of sometimes calm the nerves down that, hey, it's an anonymous access, yes, but this is an access that is embedded in the code that our customers are going to use. It's not going to go into the hand of consumers. Okay, this one shows the registration if that endpoint happens to be a DM that we know and the associated itself. It's going to convert that signaling into SIP on the back end. So I think I don't have to talk too much detail about this call flow. This call flow here talks about the whole call getting established, just tells you, it gives you the flavor of what's happening from that API perspective that's part of this offer, what kind of exchange happens on the API front. I'm going to skip this for now. So let's touch a little bit on scalability and availability, of course, important topics. So the scalability model that this gateway has right now is something like this. You could pretty much have multiple instances of this gateway and have a load balancer, pretty much standard HTTP load balancer in front of it. So that way you could scale up. So that is a very basic model. What I want to point out is that right now it is not sharing the session state, so it won't allow hot standbys. If we talk about availability, it's not supporting availability. So if you have a media call RTP established through this gateway, what it does is it is giving the token to the client-side code, the JavaScript, and which is embedded in our API. So if API on the browser side detects that there is a failure, it can reestablish the call. However, the session state is not being propagated to the different instances. So very simple model. I'm trying to, of course, go a little bit quickly here because we are running out of time. But a very simple model of scalability. Just throw in as many servers you want, have a load balancer in front of it. Availability right now, not hot standby, but we are trying to make it easy by giving that script an ability to reconnect because it has some session information. The performance numbers are not out yet, but if I have to give you a little bit of a heads up, of course, the right answer always is it depends. It depends of transcoding and all of that stuff. But I would say that it is very fair to say that about 50 to 100 range would be a good ballpark number that will support. Now different codecs and transcoding, as I said, will have different implication, and we're expecting that performance number will be out as it becomes generally available sometime in Q1 or so. However, that 50 to 100 number, at least it makes me very comfortable talking to the customer because most of these customers that we talk to right now, they're talking about 20, 30, 40, 50 seats, and if you throw that load balancing on top of it, just throwing multiple server, I think that gives a pretty much good scale. It's not something that would be a showstopper in the conversation. So at least I'm not worried. I don't know if you guys differ with that opinion. Quality of service. On the quality of service aspect, there are lots of things to look into. The short answer, of course, is that the WebRTC open standard, the browser is handling it. It has the power of Google and all the other companies that are supporting it to make it work and happen. It will be as good as Skype and others. But of course, there are lots of other things that we can at least know about a little bit better to have that smart conversation with the customer. So, so if I have to just sort of point that out before going into the codec details, I will say that simple answer, of course, that I just discussed. What we should say is the best of the video and H.264 and VP8, soon VP9 audio codec and Opus will be used. So this is part of the standard. They're the best codecs and technology that's out there, and they are being used. Genesis is not providing that. It is being provided by the standard itself. So that, and Chrome, now just to give you an idea what the browser does, right? So what Chrome would do is it will start with about 300 kbps, and it could go as down as 50 kbps and go as up as 2 mbps. So it will try to establish the connection based on the available bandwidth that is out there. Now, some of you might have done that calculation of what's the bandwidth that is necessary for good voice quality, what is the bandwidth that is necessary for good video quality, right? So I think voice quality, even around 50 kbps, 70 kbps is probably not bad, and for video, it can start happening from 100 to 100 kbps, 200 kbps, but definitely 1 mbps or so. So I think most of us, I'm pretty sure on this bridge, and a lot of customers, at least in North America, we have decent connection. We've been using YouTube, So I think bandwidth itself is not really the main issue. The main issue is, are those packets being the congestion control that it needs. Again, the WebRTC standard sort of tries to handle that. I have some link later in the presentation to talk about it. So yeah, so this is just at a very high level, but let's look at a little bit details. So if you talk about quality of service, I think the interesting thing is that when we talk about AVI, when we talk about MP4s, right? So there are three things to talk smart about this, especially about the codecs. That one thing is that whenever we talk about the MP4s and the flash and AVI files, these are actually containers. They're like zip files. And when your codec will see it, of course, have to open up this container, and it has to read what's embedded inside it in terms of audio, video, and the metadata that it has. But these are just the containers. The MPEG-4, which was part of sort of QuickTime and Evolve, OGG, which usually has open source, including video, the Theora, and audio Orbis, Flash, and the AVI. So these are, and OGG comes up a couple of times too. So I think to talk smart, you have to know that these are containers. These containers include audio and video codecs related files that are inside it and some metadata. The main tussle about these codecs in these containers is that some of them are proprietary, some of them are free. So that's the main issue, right? The proprietary ones say, of course, that they have best quality, but of course, now H.264 and VP8. So this is a little bit of a tussle going on out there. H.264 is supported, and it is a patented codec which has some charge associated with it. The main drive about H.264 was the fact that let's build one codec that can adjust in the variable bandwidth, right? So there are different profiles. So iPhone support baseline profile. Flash would support baseline and main profile. So baseline and main profiles are sort of part of the codec as it embeds and encodes and decodes, depending on what kind of bandwidth will be available where this file will be played, right? So the one codec is trying to adjust to different variation that can be out there. Now VP8 is from On2 that Google acquired in 2010. What Google did is something smart, just to differentiate, I would say, but very good for us. They took this VP3, VP8 technology, they made it open source. They made it free, and it is questionable whether VP8 is better or H.264 is better. However, what VP8 will say that they can match even the high profile of the H.264 codec, for example, even in low bandwidth, so low decoding complexity, right? But the main part is that VP8 is free. It is part of what this WebRTC technology is making open source. So Google is trying to make sure that VP8 is the codec of choice, and Microsoft and other CAMs, want sort of saying that, hey, you're saying it because you own it. It's the X264 that we want to stand behind. Now on the audio side also, we have about 5 or 6 minutes left. I'll try to wrap up quickly and see if there are any questions. But the audio side also, there are different codecs. And, so Vorbis is one of them. Audio-video codecs, you guys have learned about MP3. So Opus is an important one, too. Now, there are lots of things, if you really want to understand quality of service properly, and I couldn't go into that details today, maybe we could have a follow-up because, WebRTC was new. I just didn't want to go into the deep dive right away. But if I have to talk about audio codecs, it's about channel, right? So you have 2 speakers, you have 5 speakers, you have surround sound. So how is that encoding happening? And does that codec allow different level of encoding? So that's, different level of channels. So Opus, for example, can support variable bit rates and how many channels each of these codecs support. So based on that, their quality would be useful. But then the important thing is that if we are talking about browser, if you're talking about internet, if you're talking about variable rate of bandwidth, then these codecs have to adjust and provide a reliable connection even in that unreliable world of internet, right? So that's really the challenge. But certainly, if you talk about video, you heard about HD quality, the 720p, the 180p, and the eyes. So you can look into those details as to what of that refresh rate is, how many lines are there in that screen, what's the aspect ratio, I guess without going into too much detail, the point is that these codecs, the quality is a complicated and challenging aspect. The good news is that the WebRTC technology and the open source community out there is working to provide the best in-class, whatever has been the development in this arena, right? It is embedded as part of the technology itself, so VP8, Opus, and those codecs. Not a lot of details, but at least some of them. Now, the last point I want to quickly mention the next minute or two is about deployment. There is a one pilot that is going on in EMEA right now. They are a bit ahead in the game in SIP and even WebRTC, so they beat us up. I think we should try to get at least WebRTC in the lab. If you guys like those use cases that I just described, I think there are certainly some use cases. But on the deployment side, we have to understand what the product supports. So the stun and the turn server are not that we provide. That is something that will be in the play. Let me just go through these slides to highlight that fact. So the RSMP gateway needs to be in DMZ because we have to expose that SRTP port. So it needs to be in the DMZ. Stun server is almost always required, and that is the server that the customer would have to pick it up. We could point to few that we use for internal testing, but that is not something that we provide. And that stun server will be outside of that firewall, and that RSMP needs to be in the DMZ. It needs to open up those ports. On the backend side, of course, on the enterprise side, it needs to have SIP and need to have connection to configuration manager as a management layer and config layer. So those things needs to happen. So if it's an agent SIP endpoint, that's how it looks like. If it's a Chrome, it's pretty much similar. Of course, the WebRTC gateway is taking care of the fact that in this case, it does not have to do SIP, but WebRTC. Of course, one use case that is supported even now in our WebRTC gateway is to have that endpoint, as I said, on a WebRTC-enabled browser. So we are providing SDKs and APIs to make it happen. So if a customer today wants to embed that in a Chrome browser for an agent, they can do it. We have all the ability in the product that we have right now to make it happen. So in that case, of course, the agent will be, let's say, working from home behind the router, and the same stun server can actually act as a channel to punch that hole and connect those consumer and the agent together. So if you take this use case and if we embed that into our HTML5 thin client browser, I think it will be pretty powerful. So here I have some links for you guys to go research. I will have some internal links too, but this, this is other slide has that other link. So with that, I'm going to stop. I know I probably was not able to go into as much detail as I would have wanted to, but those, that initial section, high-level section, was also something that I want to highlight, this being new for quite a few folks out there. So let me stop there, Dan. Let's see if you have any questions, and I'll try to see if there are questions on the GoToMeeting itself.
Okay, so more of a comment. Vadim shared a very tentative schedule for WebRTC in the cloud is targeted for mid-2014. So we'll that they are looking at it to add that into the cloud solution, and looking at hopefully sometime mid next year. While you're looking at Deepak, I just want to say thanks to you for pulling this information together. I've gotten several comments from folks saying this was good information and a good session, and I know you took a lot of time pulling this information together, so thank you for doing that. We will have we'll get the presentation and the recording posted out in our chatter group, North American G-Factor group. Those will get posted out either later today on Monday, and there will be a skills assessor quiz on this that I'll send out the information for as well. So Deepak, did you have any other questions?
Nope, that's it. Thanks a lot. Thanks all for being here. And if you have any follow-up questions, yes, feel free to reach out to me. I have provided some links as well, so I think that will be useful for you guys too. And we could probably have a follow-up session and have a deeper dive into all of those cases if it is required.
Okay. Thanks again, Deepak, and everybody else for your time. And